Welcome, scholars, back to Mr. Honeycutt's math class. All right, for this little video, we're going to work just on factoring the difference of two squares. Again, this is one of these big patterns. So this is what it is. So a squared minus b squared is equal to a plus b times a minus b. What I first want to show you is that it actually does work. I think sometimes scholars are like, wait, really? This actually works? Yes, it really does. So let's just say that a equals 7. All right, so I'm going to plug a 7 in for a. And then we're going to use a b of 2. All right, so 7 squared is 49 minus 2 squared, which is 4. Hey, that's going to be 45. Well, 7 plus 2, hey, that's 9. 7 minus 2, hey, that's 5. And then 9 times 5, hey, that's 45. Hey, 45 is equal to 45. Isn't that great? But yeah, and this always works. It really, really does. You can prove it. You can do it geometrically. I've done things with shapes in previous classes before. But this pattern is one, it's so common, you need to be able to recognize it. I can just about guarantee it's going to show up on the ACT. I can just about guarantee it's going to be on your IB exam. And some of the problems that it's just a common, helpful pattern. This a squared minus b squared is a plus b, a minus b. All right, so let's just do some really simple ones. So x squared minus 81. Well, that's my sort of a squared minus b squared. So I've got to just factor in, okay, so if my x is a, so that's x minus, well, b squared, hey, that's 9. Hey, it's a good thing you had a teacher make you memorize your squares. That was so nice of some teacher that you had. So x minus 9, x plus 9. Now, what's weird over here is you might want to rearrange these. And to think of this, you can think of this as like 2x squared minus 9 squared. You can kind of force them into that a squared minus b squared pattern if you need to help you see it. And then you can just rewrite so that it's 2x minus 9, 2x plus 9. Obviously, it doesn't matter where the plus or the minus goes first. But yeah, so this is the pattern, and you've seen this before, but it really does always work. It shows up quite a bit. Yeah. Now, let's look at the meta pattern. So, my a is now an expression, 2x minus 7. All right, and then my b is the 81. So, well, what's my a? So then I'm going to have 2x minus 7 minus 9. And then I'm going to have 2x minus 7 plus 9. And then I am going to want to simplify these. So then this is the same as, say, a 2x minus 16. And then this is a 2x minus 7 plus 9, so that's 2x plus 2. And that's what that factor pattern is going to look like. And then notice we could do something even where here my a is the 2x minus 7. And then I could also do, hey, what if my b is like a 3x plus 8? It's going to get kind of complicated. I'm going to make a little room over here. All right, maybe I'll use like a big bracket. So I've got a 2x minus 7 minus 3x plus 8. Honestly, I think I'd put the minus first just because it's there like in the expression so that I just remember that it's there. And then times 2x minus 7 plus 3x plus 8. Bracket. And then I can combine these. Do remember that this negative here is going to distribute. So it's going to go to the negative 8 as well. So I'm going to have 2x minus 3x, so that's going to be a negative x. And then negative 7 minus 8, that's going to be a negative 15. And then I'll have a 2x plus 3x, so that's going to be 5x. And then a negative 7 plus 8, that's going to be a positive 1. So that's what that would look like. Again, this part looks weird, okay? And it doesn't look like an a squared minus b squared sort of thing. But what matters is that sort of meta pattern thing. Now, for these ones. This is x to the fourth. You can think of these as, I can think of this as x squared squared, okay, minus 9 squared. So then I can break this up, and I can do an x squared minus 9 and an x squared plus 9. And what's crazy is this one is the 9 over here is also squared, so I can actually split this one again. So that's going to be an x minus 3, x plus 3, and an x squared plus 9. So notice I can split it again. And then, hey, look, I can do these sorts of patterns with trig. Remember that this one, so hey, here's my meta pattern. So remember, we can think of this as secant x all squared. And 1, we can also, 1 times 1 is still 1. So I can think of that as a b squared. So anytime you see a 1, it can also be a b squared. You got to remember that. This is one of those things I think you guys are going to get kind of stuck on, like, oh, I don't know what to do with the 1. Remember, there's the implied squared. Remember, when you get stuck, it generally means you're forgetting about implied notation, all right? So when you get stuck, that's like kind of part of your little checklist. Like, am I forgetting about implied notation? Yes. Yes, I am. All right, so again, the a minus b, a plus b. So that's the meta pattern. That a minus, this like chunk minus chunk times chunk plus chunk, all right? Hopefully you're starting to see a little bit of how this works. That it's not just about individual variables, but it's about how expressions and groups of expressions can actually kind of work together and factor together. Once you start to see that and are able to group and ungroup as necessary correctly, algebra is going to get a lot easier. So please do the difference of two squares portion of Delta Math. And I will warn you, not every exercise will be a difference of two squares. I just couldn't quite make it do that. But most of them should be. So.